What if every asteroid hit Earth at once? Not one asteroid. Not the one that killed the dinosaurs. Every single asteroid. All at once. Right now, it sounds like science fiction, but it is a real nightmare that scientists have actually modeled, and the answer's way worse than you think. First, how many are we talking about? When you picture an asteroid belt, you probably picture a crowded field of rocks, like in the movies, where you have to swerve to avoid them. Real space is not like that. The asteroid belt between Mars and Jupiter is mostly empty. If you stood on one asteroid, you probably could not even see the next one. But there are still a lot of them. NASA has mapped over 1 million asteroids bigger than half a mile wide. There are about 150 million asteroids bigger than a football field. And if you count every rock bigger than 30 feet, like a small house, there are billions. Billions of rocks, all orbiting the Sun. Together, all the asteroids in the asteroid belt weigh less than our Moon. Less than 4% of the Moon's mass. But that does not matter. Because if they all hit at once, Earth is done. So let's press the button. At second zero, every asteroid is magically teleported into a collision course with Earth. Not gradually. Instantly, from all directions. The first thing you would see is the sky lighting up. Not one shooting star, but millions. The atmosphere would start to burn. The smallest asteroids, the ones the size of cars and houses, would burn up 40 to 50 miles up. That sounds safe, but it is not. Each one exploding in the atmosphere releases energy. One small asteroid exploding is like a nuclear bomb. 1 million of them exploding at once would heat the atmosphere to thousands of degrees. The sky itself would glow white-hot. The air would become an oven. If you were outside, you would be cooked instantly. Not by impact, but by the heat of the sky. Forests would ignite spontaneously. Paper on your desk would catch fire from the thermal radiation alone. Then the medium ones arrive. Asteroids the size of football stadiums. Asteroids like Tunguska. In 1908, a rock about 150 feet wide exploded over Siberia and flattened 800 square miles of forest. That was one rock. Now imagine 150 million of those hitting every continent, every ocean, every city at the same time. Each impact would create a fireball hotter than the surface of the sun. The shockwave would flatten everything for hundreds of miles. The sound would be so loud it would deafen everyone on the planet instantly. There is no place to hide. If you are within 500 miles of a medium impact, you are vaporized. If you are within 1,000 miles, you are killed by the blast. And there is an impact every few miles. The blast waves would overlap and circle the Earth multiple times, and we have not even gotten to the big ones. There are about 1,000 asteroids bigger than 6 miles wide. The one that killed the dinosaurs 66 million years ago was about 6 miles wide. That one asteroid hit the Yucatan Peninsula, released energy equal to 10 billion atomic bombs, created a crater 100 miles wide, caused earthquakes that rang the planet like a bell, triggered volcanoes in India, and threw so much dust into the atmosphere that the sun was blocked for years. Plants died. Dinosaurs starved. 75% of all species on Earth went extinct. Now imagine 1,000 of those. At once, Ceres, the biggest asteroid, is 580 miles wide. It is a dwarf planet. If Ceres hit Earth, it would not make a crater. It would melt the crust. Vesta is 326 miles wide. Pallas is 319. Hygiea is 270. Even if only the top 10 biggest asteroids hit, the energy released would be enough to boil the oceans, literally. The entire surface of the ocean would turn to steam. So here is the timeline if every asteroid hit at once. In the first minute, the atmosphere heats up to over 1,000 degrees. Every flammable thing on the surface catches fire. The sky turns from blue to orange to white. In the first 10 minutes, the medium asteroids start impacting. Each one hits at around 12 miles per second. That is 36 times faster than a jet. When they hit, they do not just make a hole. They release all their kinetic energy in an instant. The rock and the ground vaporize. A superheated plasma jet shoots back into space. The ground ripples like water. Earthquakes of magnitude 12, bigger than anything ever recorded, race around the globe. In the first hour, the large asteroids arrive. Ceres alone would hit with the energy of 10 to the 29th joules. That is a number so big it is meaningless. For comparison, the entire nuclear arsenal of the world is about 10 to the 19th joules. Ceres is 10 billion times more powerful than all nuclear weapons combined. Its impact would punch through the crust 30 miles deep into the mantle. The mantle, which is normally solid rock that flows slowly, would splash like water. Molten rock would be thrown into orbit. Some of it would form a ring around Earth. Some of it would rain back down as lava for months. The oceans? Gone. Not from one impact, but from the combined heat. If you dumped all the asteroids into the Pacific Ocean, the water would instantly flash to steam. The steam explosion alone would blow the atmosphere off into space. The entire atmosphere would be stripped away and replaced by vaporized rock and steam. You would not be able to breathe, not that you would be alive to try. After 24 hours, Earth is unrecognizable. It is no longer a blue planet. It is a glowing red and black ball of molten lava. The surface temperature is around 3,000 degrees Fahrenheit. There's no ocean, no atmosphere, no life, no buildings, no evidence that we were ever here. The crust has been completely melted and resurfaced. The planet has been sterilized. How long would it stay like that? For a long time. After the dinosaur asteroid, it took Earth 3 to 5 years for the dust to settle and sunlight to return, and 10 years for the planet to cool enough for plants to grow again. After every asteroid, it would take millions of years. The new molten surface would have to cool and harden. Volcanoes would erupt everywhere for hundreds of thousands of years. Acid rain made of vaporized rock would fall. Then, eventually, after maybe a million years, water vapor would condense and form new oceans. But they would be boiling oceans on a dead world. Could anything survive? No. Bacteria deep underground, maybe 2 miles down, could theoretically survive the heat pulse for a little while. But the crust melting, the global magnitude 12 earthquakes that shatter the entire crust, and the boiling away of all groundwater would kill even them. This is an extinction that makes every other extinction look like a bad day. So how worried should we be? Not at all. Gravity keeps the asteroids where they are. The asteroid belt is stable. It has been stable for 4 billion years. Jupiter's gravity keeps it from clumping into a planet, but it also keeps it from falling inward. An asteroid hitting Earth is rare. A 6-mile asteroid hits once every 100 million years on average. All of them hitting at once is physically impossible, unless something truly insane happens, like a rogue star passing close to the sun. We track the dangerous ones. NASA's Planetary Defense Coordination Office tracks over 30,000 near-Earth asteroids. None of the big ones are headed our way in the next 100 years. We even proved we can push one. In 2022, NASA slammed a spacecraft called DART into an asteroid called Dimorphos and changed its orbit. We have the technology to stop one, but if every asteroid hit at once, there is no technology. There is no bunker deep enough, no plan smart enough. It is not a disaster movie where a few heroes survive. It is the end of the Earth as a planet with a surface. So the next time you see a shooting star, make a wish. That is a tiny grain of dust burning up 60 miles above you. It is beautiful, and it missed. Because if it did not miss, if all of them did not miss, we would not be here to watch it at all. We live on a planet that, for now, is safe, and that is more luck than you will ever realize.